Welcome to all. I am Prabhas Shukla, Faculty of Computer Science Engineering Department, and today I am going to discuss with you the types of attribute in an SDT, means syntax directed translation scheme. Okay, so there are basically two types of classification regarding the attributes of SDT. The first one is synthesized attribute and the next one is an inherited attribute. Mainly these two classification, and further there are some more classifications. Okay, so what is synthesized attribute? So here I have taken an example. Let's say A turns to B is BC is a production of a grammar, okay? And A's attribute is depend on B's attributes and C's attributes. Then it will be synthesized attribute. This is the basic definition. And here I have taken an SDT where A turns to BC, and this one is the semantic rule corresponding to this production. Suppose if I am going to draw the parse tree for this particular production A turns to BC, okay, and in this segment, and here I have also mentioned that dot s is an attribute. Uh, in my previous lecture, I have discussed some SDT where we use such type of notation, but at that time I was not discussed. Okay, so here you can see what is an attribute. So anything which is written after the non-terminal followed by dot and then this one. So you can see here s is an in the role of attribute. Okay, okay. So and this is just a sample of a production. Maybe there are some production which is uh, which is initiated from the non-terminal B and non-terminal C. So this is not a complete grammar. It is just a sample. Okay, so suppose if such type of tree we have designed it. Okay, so if we are going to evaluate this parse tree. Okay, so the order of evaluation is similar. I have already discussed in my previous lectures. So the order of evaluation is always left to right and bottom to up. It means first of all B is processed, then C is processed, and then A turns to BC is processed. Here I am showing the subtree of node B and the subtree of node C. Okay, so you can see from this semantic rule the value of A node is depend on the value of B node plus the value of C node. It means whenever we are going to whenever we are calculating the value of a parent node with the help of their child node, such type of notation or such type of SGT is categorized in synthesized attribute category. So this is the overall concept behind synthesized attribute. Okay, we will move into my next attribute category, and that is an inherited attribute. 1 minute. In this sorry, inherited attribute is another classification of SDT. Okay, so here you can see that, let's say A turns to B. My example is similar. Uh, let's A turns to BC is a production of a grammar and B's attributes is depend on A's attributes or C's attributes. Then it will be inherited attribute. Means suppose in this SGT, this is a production and this is corresponding SGT. Here we have seen that in this SGT there are two tasks performed on the reduction of this production. Uh, B value is calculated with help of A values and B value is calculated with help of C values. Okay, so here I have again draw the parse tree. A turns to BC. Okay, and if we are going to evaluate pass tree in this manner, okay, and this is a subtree, this one and this one. Okay, with the help of subtree, I'm going to show that there is some more production, and the value of B is calculated with help of these subtree, and the same system is follow here. The value at node C is calculated with help of these subtree. Uh, Here you can see that this action suggests that the value of B node is calculated with help of node A. Means the value of child node is calculated with help of the value of parent node. Okay, and here the value of B node is calculated with value of C node. Means here the value of B is depend on the parent node, and here the value of B depends on their sibling node, because B and C are sibling. Okay, so such type of SDT is known as an inherited attribute. Means whenever child nodes value depend on a parent nodes or their sibling nodes, so this type of SDT is known as inherited attribute. The next is the next is S attributed SDT. Here S attribute SDT is nothing but if an SDT uses only synthesized attribute, it is called an S attribute. Means those SDT whose attribute is whose who has only synthesized attribute, it is also known as S attributed SDT. Okay. In the next point, I have mentioning that S attribute SDT are evaluated in bottom up parsing, as the value of parent node depends upon the value of the child node. I have already point out this statement. Okay, and the semantic action are placed in a rightmost place of the right hand side. So the semantic action means these actions. So these actions placed are in the rightmost place of the right hand side. Okay, the next is an L attributed SDT. L attribute SDT, here you can see the definition. If an SDT uses both synthesized attribute as well as inherited attribute, with the restriction that inherited attribute can inherit value from left sibling only, it is called L attribute SDT. Okay, attribute in L attributed SDT are evaluated by depth first and left to right parsing manner. So the same approach is here, and here I have taken an example. A tends to XYZ, and here is three actions performed on the reduction of this production. The first is this, the second is this, and the last one is this. Check. Every action is separated by a comma. So suppose if we are going to reduce this one, A tends to XYZ. I have just draw the pass tree. A tends to XYZ, and if we look at here, in this action the value of y depends on the value of A. So value of y depends on the A. This is the property of inherited attribute I have already discussed with you. And in this segment, the value of the value of y is calculated with the help of their sibling x. So this is also the part of inherited attribute. And the next one is the value of y is depend on the value of z, and y and z also a sibling. Okay, but here is the but here in this action there is a problem. What problem? You can see from here, the inherited if an SDT uses both synthesized attribute and inherited attribute with restriction that inherited attribute can inherit value from left sibling only. Left sibling only. And actually here the Z is the right sibling of Y. Here the Z is the right sibling of Y. But here you can see that the Y is, sorry, the X is left sibling of Y. So that is the rule. That's why here we have concluded that this is not an L attributed grammar. If we remove this rule, then the overall SDT is known as L attributed SDT, otherwise it is normal at SDT. Okay, here you can see the set of L attributed SDT and S attributed SDT, and you can easily observe that if a definition is S attributed SDT, then it is also L attributed, but not vice versa. Means if attribute is S attributed SDT, it means, yeah, but obvious it is L attributed SDT. But if any SDT is L attributed SDT, so it is may be S attributed or may not be. If it is belong here, then it is S attributed, and if belong here, then it is not S attributed SDT. So that's why we mention here this is not a vice versa.